Hello and welcome to today's problem. So the problem today is going to be named reverse integer, and this is a medium level problem to solve, and it describes as the following. So we're going to have a reverse function that's going to take in the inputs an x, which is an integer, and this integer we should return the reverse of the integer. So these are some examples. So in this example 123 is going to be returned as 321, so basically reverse it, and minus 123 is going to be written as minus 321, and 120 is going to be reversed 0 to 1, which is 21. Yeah, some conditions basically in the exercise, which is that x is going to be a 32 bits integer, which means that it's going to be between minus 2 to the power 31 and 2 to the power 31 minus 1. In this case, like imagine if the reverse number is beyond this interval, we should return 0. And another thing to consider is the computer is going to be able to support more than 32 bits. So imagine that we go beyond, so nothing is going to be breaking, but of course we should consider this. So I prefer that we don't even need to go beyond this integer, because in some computers that might break, but in this case they say it's not going to break. So let's do some sketching so we can understand what's the problem. So yeah, so this is basically a representation of the boundaries that we have. So we cannot exceed this as a minimum limits, and this is the maximum limits. As you can see, 2 to the power 31 is this number, and we're gonna go back to it in a bit, but let's understand the solution. So I propose two solutions. The first one is gonna be the go-to, like most people are gonna use to solve the problem. I don't think it's the best, but the second one is, in my opinion, the best. I'm gonna explain why in the process. So if we take, for example, as an input 132, people, they will convert this to an array, and after that they're gonna reverse the array, and then they're gonna join the array to a string, and then this string is going to be parsed as an integer, which is 321, and this is the result that we should return. How in the negative case, so if we have minus 123, this we're gonna like take this information and say is negative as true equals true. Sorry for the bad writing. And then we're gonna only take the positive value, and we're gonna apply the same process, and at the end multiply the results by minus 1. So it's fairly simple. Let's code it quickly, and then we're gonna pass to the second solution that I'm more interested by. So we're gonna convert x to a string, and then we're gonna take the value if it's negative. So I'm gonna say is negative. I think it's a constant. It's a constant. It's not gonna change. So is negative is gonna be basically if x, I'm gonna say if x less than a 0, then I'm gonna say is negative. Let's do it better. Let's const is negative. So if x smaller than 0, I'm gonna say it's true, otherwise it's false. And then we're gonna start doing what we said. So I'm gonna like take the string and I'm gonna like split it to make an array, and then reverse it and then join it. So what is this? So basically we split this the number. Now we're gonna have from this an array of numbers, and then we're gonna reverse it. So this is gonna be returned. We're gonna have an array of the reversed numbers, and then we're gonna join them. This is gonna be a string, and then we want this as an integer. So I'm gonna parse it as an int, and I'm gonna call this result. And so all we need to do is if is negative is true, just gonna say result equals to result multiplied by -1 and return results. However, there are the case if we go beyond basically the boundaries that we just described here. So if result is bigger than, we say 2 to the power 31 minus 1, so 2 to the power 31 minus 1, or result is less than minus 2 to the power 31. So minus 2 to the power 31. So if this is true, we should just return 0. And let's check that this solution is working. Parse int. This is a, let's see if there is any. All right. Result. What's the problem? Split. Sorry. I should split on the string. And again, it's a join. Yeah, so this is a really good solution. However, there is a case where the result is bigger than what is supposed to be a 32 bits. So basically, we can, if the computer cannot support more than these values, this is going to be a problem. Yeah, and this result in this case is basically represented in the 64-bit. This is why there is no problem in this case. So let's see how can we do another solution without being in this problem. So we're gonna have again the same thing, and we're gonna have a variable that we're gonna call result, and I'm gonna initiate by 0. So all I need to do is basically take all the time the last number. So this is x, by the way, and I'm gonna pop this last number, and I'm gonna like assign x to the rest, the left side. So x is gonna become 1, 2. So all I did is take 3, divide the number into 2 parts, the rest of the division by 10. So this is x divided by 10, and this is the rest, and this one is x minus this number divided by 10. And then all we need to do is result is going to equal to this value, the previous value, times 10 plus this one, which is the pop. We call it pop. So 3. So the new value of result is 3. And then we're going to do it again. So we're going to take 2, and then we're going to take 1. We do it again. So 3 times 10 plus the new pop, which is 2. So it's 32. And then we're going to do it again. So 1 and 0. So we're going to do 32 times 10 plus this one. And because we arrive at 0, so we cannot basically split it, we just need to return the value of result, which is this one. So let's try to code this solution. So I'm going to create a variable, as we said, results, that I'm going to initiate by 0, and our goal is to return results. And then we're going to do a loop while x different from 0. We need to keep going. So basically we're going to create the pop, which is x. So the rest of the division of x by 10, this is the pop. And the new value of x is x minus pop divided by 10. So it's quite simple. And then we overwrite result by result times 10 plus pop. So it's very straightforward so far. As you can see, I've just described exactly what we did here. But there is one thing we should consider is every time there is a new value of result, we can basically compare it to this value. So if it goes beyond, that means that we exceeded this 2 to the power 31 minus 1. If it's equal, we need to check if the pop is bigger than 7. This is if we are going toward the right direction, which is the bigger threshold. If we go negative, so also we need to check if result is smaller than minus this. And if that is the case, then we need to compare pop and see if it's smaller than 8. And if that happens, then we need to return, in both cases, 0. So let's do that. So basically, I'm going to be comparing result. And I'm going to say if it's bigger than 2 to the power 31 divided by 10. So this is the first condition, or result is equal to 2 to the power 31 divided by 10, and pop is bigger than 7. So basically, I described if we are going beyond the upper threshold. In this case, what do? We just return true. We return 0. And we should do the same if we go basically negative. So if result is smaller than minus 2 to the power 31 divided by 10, or result is equal to minus 2 to the power 31 divided by 10, and pop is smaller than minus 8. If that happens, we should return as well 0. Of course, we can combine these two ifs into one, but you get the idea. So, and there you go, the solution works fine. And in this case, we never created a variable with more than this interval, and also we never created any arrays or We only created variables, which is really good for memory performance. Yeah, so I hope that you liked this solution. If you have another solution, you can post it in the comments and I'm open to discuss. And please give a thumbs up to the video and consider subscribing for more videos. I hope to see you in the next one. Bye bye.